Hi everybody, welcome to Calculus 1 review. You will see the list of the questions that we have done on that side, and there is a timestamp in the description. Right, the first one, we find the limit when x approaching to -1. So -1 is here. But when x go to -1, we just see what happened to the function. Again, this is what happened close to it. So this is x equal to 1, -1 is this. We have to go along the function. So if we go along the function on the left side, when it approaches to the edge of the ruler here, it approaches to this point on the left, and on the right we go along the graph, and it approaching from the right to this point as well. So whatever the y values of this point is, again, whatever the y values of that point is the limit of the function. So that look like here. So if 4 grid is equal to 4, so this is 3 of those, so 3 over 4. The values of the function, this dot is irrelevant, we don't need that. So that's the first question. Times 10. Right. Next, we'll find the limit, but on the left side and on the right side. So let's take a look at this. Limit when x go to -1 from the negative sign. The negative superscript meaning that the function will be from the left of -1. So this is -1, and we go from the left, we trace the function, and on the left we approach to this point. The y values of that point is -2. So that's all we have. And then the limit of the function when x goes to -1 with the superscript plus, meaning from the right side. So we trace the function, go along with the function, and on the right side of -1 it approaches to this point. The y values of that point is -7. And with that, the limit from the left and the limit from the right do not agree. The question did not answer, by the way, but we can also say the limit when x go to -1 did not exist. That is 2. Right, next we need the calculator to find the values, and from there we find the limit of the function. Right, let's use calculator. Put that here. Good enough. Right, so first we're going to enter the values into the function. I will hit y equal 2, and we'll enter the function. If you use in the TI-84 or something like this, when you hit alpha and y, if the bottom menu pop up like this, hit enter. That allows us to enter the fraction. If not, we just use the parentheses. That's perfectly fine. X minus 4 on the top divided by x squared minus 5x plus 4 close parentheses. Usually when we need to find the values, we hit second table. But this is not going to work because we have the 3.9, not exactly values on 0, 1, 2, not integers. So in that case, hit second trace. The first option is value, so second trace and enter. Right, then we'll grab the function and we'll ask you what is the x values equal to. So x equal to, we just enter 3.9, and that is 0.3448. Let's keep 4 decimal places, and then we enter 3.99, and then we don't have to hit second trace again. We just hit the add new value for x, and that gives you the y values. Bigger calculator. So that is 0.3344, and then 3.999 have 0.333, 4.001, 0.333. Oh, that was 4, and then 2. 4.01, zero point 0.3322, and 4.1, 0.3226. Right, so those are the values. Let's put the calculator away. Right, so those are the values. Now x go to 4, so 4 is right in the middle of this. By the way, I need to show you this as well. If we hit 4, this is undefined, so we cannot do that. Right, so the limits. So 4 is right in the middle here. We just need to see what is the pattern, what is the trend when it goes like that. So it looks like it is going to be 0.333, and the next one between 4 and 2, so that should be 3 and 3, and I assume we suppose it look like that, which is about 1 over 3. Actually, it should be exactly 1 over 3, but numerically we can just say is 0.3333. Right, so that was 3. The next one should be easy. Find the limit of the function when x go to 2 from the left hand side, that negative sign. So we have 2. If it goes from the left side of 2, we're going to have something less than 2. If less than 2, we must use this function. So we say the limit when x go to 2 from the left side of the function, we're using negative 2x minus 7. And then the first rule of limit, put in a number. So we have negative 2 times 2 minus 7. That gives us negative 4, negative 7, that negative 7, negative 11, and that's a nice number. So by nice I mean it is defined, so that's negative 11. So that is 4. Right. Now we find the limits. The first rule of limits is, except for piecewise function, it's a bit tricky, but other function, we're just going to put in the numbers and see what happens. So I substitute x into 0 into x for number 5 here. So we have 8 over negative 2, which is negative 4. Since it is defined, we will make the limit equal to it. That's simple enough. We do the same thing for 6, but let's just write a timestamp. And that was number 5. Right. 6. First we put 6 in for x. Alright, so that is 36, 24 minus 60, and that is 0. So look like we have 0 over 0. 0 over 0 is one of the indeterminate form. So in that case, it could be anything. So we don't write that equal to here. What we write is, even though it is 0 over 0, doesn't help us much, but it helps us a little, because it is equal to 0 when x equal to 6, meaning that 6 is a 0, meaning x minus 6 is a factor. So let me write that again. If f of c equal to 0, which means c is a 0 of a function, then x minus c is a factor. So both of them have x minus 6. The bottom obviously only have x minus 6. So the top we need to have a factor. Multiply will give us x squared plus 4x minus 60. Right. To get x squared, we're going to need the x, and to get negative 60, that's going to be plus 10. And both of them have x minus 6, so they cancel out. So we have 6 plus 10 is 16. Right, next. This one has the square root. Usually when the square root we use the conjugate, but don't assume that, just always put in the numbers and see what happens. So I'm going to put in 4. The top square root of 4 is 2. 2 minus 2 is 0. So indeed we have 0 over 0. Right. So we could still factor, but we use the conjugate here, meaning that if we have a minus b, then a plus b is going to be, a plus b is the conjugate. When we multiply it out, it should be a squared minus b squared. So we will That is original problem. And then we say, which one do we use? Do we use x minus 4 or we use square root of x minus 2? And the answer is always the one that has the square root, because we're trying to eliminate it. So we multiply the conjugate of that. So we could just multiply it out. I will multiply it out the top, square root of x times square root of x. That is square root of x squared. Of course, later on, the square cancel the square root of x. And then 2 square root of x minus 2 square root of x. 2 then 2, that's 4. Cancel out the middle terms. The bottom, x times square root of x, but we don't do that. Remember, kind of like the previous problem, because both of them equal to 0, so we expect to have the common factor of x minus c, this particular x minus 4, so we should keep the x minus 4 because that will cancel with something. We'll see. The top actually is x minus 4. The bottom is x minus 4 square of x plus 2. Cancel the x minus 4. We have 1 over square root of x plus 2. If we put 4 in for x, I know it's going to be a defined number, so I'm just going to write equal to. So that equal 1 over 4. And that is 7. Right. 8 and 9. I'm just going to do 9. So what we do is we just put in the numbers. If it is 0, then we have to worry about if it is on the right side or the left side. Actually, I think I'm just going to do both. So if I'm going to put negative 3 in here, we have 1 on the top. Negative 3 plus 3, so we have 1 over 0. If it is 0, then we have to worry about if it is on the right side of 0 or on the left side of 0. So to do this, we have the number on the left side of negative 3. So if we want to, we just go negative 3, and on the left side of negative 3, which is smaller than negative 3, so we subtract a very small number. So that gives us something that is on the left side of negative 3. I will store into x. Right, so x will take that values, and then we just have 1 over, no, we don't need to have 1 over, we just have x plus 3 at the bottom, and that is negative, so we're going to have negative, and 1 over positive over negative is negative infinity. So this one is equal to negative infinity. Right. The next one, we cannot really use secant in the calculator, but we can only use sine, cosine, and tangent. And secant is 1 over cosine, so we have to use that. X go to negative pi over 2 on the left side. Right, Van point here, it have to be in the radian mode. Switch mode, make sure it is on the radian mode. Right, so that's good. Then we have just negative pi over 2. This one on the left side as well. So we subtract a very small number. And let's store that to x. and then do cosine of x. So that's going to be negative. So the top we have is 1, the bottom is cosine of pi over 2 is 0, by the way. Okay, sorry, shouldn't rush this. First we're going to put in pi over 2, negative pi over 2, and that is 1 over 0, and we see that it's actually 0 from the left side. So that is negative infinity. Right. So it should be B. Right, so what's wrong here? I mean, it's compared to the key on the back. So second, first we have the cosine function. So that is cosine, and the second is bouncing. And where it's equal to 0, we have the vertical asymptote. So secant is 1 over cosine, and cosine is that. Actually, we can just graph 1 over cosine. Yeah, so it looks like that. Wait. Yeah. So y 1 over cosine, so that's what we have. Right. And then pi over 2, negative pi over 2 is about here. And on the left side of it, so this is, it goes to this point here. So this is actually negative infinity. So it's not A. Right. Next, try to find the vertical asymptotes of this function. So the vertical asymptote, kind of like this problem, is where the function is undefined. So it's only happened when the denominator equal to 0. So let's just say vertical asymptote occurs whenever the function is undefined. And the only thing that make it undefined is the bottom equal to 0. So for this problem, we have x plus 4 equal to 0. So x is equal to negative 4. We're not going to say x equal to negative 4 is the vertical asymptote yet. What we need is make sure that the limit goes to negative or positive infinity. So we find the limit. We put in negative 4. Sorry, I forgot to update the list. Forgot the timestamp also. Worry about that later. And then 0. Right. So this one we can just consider the left side or the right side. If we take the left side or the right side, doesn't matter. I use the right side here. Something bigger than negative 4 add to that, so it's going to be positive. And that will be negative infinity. We only need to have positive or negative infinity, and we only need the left side or the right side. So here I use the plus. You could use negative, it doesn't matter. Regardless, the function goes to negative infinity when x goes to negative 4. So x equal to negative 4 is the vertical asymptote. Times 10. And that was 10. Next we have the limits at infinity. So what happens when x, where the variable goes to infinity? So where a variable goes to infinity, only the highest power terms matters. So that's a guideline that we have here. As x goes to either plus or minus infinity, only the highest power term matter. Right, so let's check the powers. Here we have square root of x. Square root of x is equivalent to x to the 1/2 power. So the power is 1/2. The 1/2 definitely bigger than negative 1. So when x goes to infinity, so this one actually just equal to the original problem. Just copy it. Right, first, let's rewrite this as the 1/2 power. And we'll take the highest power on the top and the highest power at the bottom. So 1/2 is bigger than negative 1, and the bottom have x to the first power. 4 has no power, so power 0 here. Alright, simplify. Negative 3 and negative 5, so that's 3 over 5. Where we divide two numbers with the same base, we subtract the exponent. By default, this is to the first power, so we subtract those exponents. That equal to negative limit when x go to infinity, 3/5 x to negative 1/2. If it is negative 1/2, we should put that at the bottom. And then when we put infinity into it, and 3 over 5 times square root of infinity, or infinity to the 1/2, infinity at the bottom, so this should be equal to 0. So we have that times 10. Right, next. Similarly, we will take the highest power because t goes to infinity. Only the one with the highest power matters. So the top just have 25t squared, and then the bottom just t. Right. Square root of 25t squared. Just have square root of 25, and then square root of t squared. Note that square root of t squared do not cancel out, because in general what we have is square root of something square is absolute values of a number, which means it will be the same if it is greater than or equal to 0 and opposite if it is negative. Right. Square of 25, so that is 5. And square root of t squared. Now t go to infinity, so that's definitely positive. So we just have absolute values of t, which turn out to be t later. Since t is positive, because it go to infinity, we're going to have 5 absolute values are positive, it itself, and then we cancel out the t, so this equals just 5. Which is equal to 5 times 10 right. We'll skip 13, just go to 14. 14. We will again take the highest power on the top, because it go to negative infinity. We can do that. Highest power on the top and highest power at the bottom. Notice we're going to have to use the whole term with the sign in front of it. Right. I don't know why I just copied from. Right. 4 divided by negative 5, so that is negative 4 over 5. And x cubed over x squared, so will be just x. Now if we put negative infinity into it, and negative, that is positive. So we turn into infinity over 5, which is infinity. So that's what we have. Next, the horizontal asymptote. So the horizontal asymptote is what happened when x go to infinity or negative infinity. So we're just going to find the limit when x go to infinity. And whatever that equal to, y equal to that values is the horizontal asymptote. So again, take the highest power. Simplify. And we put in infinity. Which is 0. So y equal to 0 is a horizontal asymptote. You still need to verify that when limit when x go to negative infinity. Actually, if we do that, we should get the same thing. Because if we put negative infinity in here, that's still the same. 1 over infinity is 0. Where that is negative infinity or positive infinity is still 0. So that's still 0. Right. Next, find the values of k, that makes the function continuous. So continuous require three things. The limit exists, the function is defined, and they have to be equal. So those three things. But first, the limit have to exist, meaning that for the piecewise function we have one side and the other side they have to come to the same point. So we say the limit of this function when x go to 6 from the left side, which is that. So we're going to have 6 from the left side of x squared, 6 squared is 36. Now we do the limit from the right side. When it's greater than 6. So that gives us 6 is x plus k. The limit exists when those two equal. So k must be equal to 30. Right. And we also define this has the equal side too, so it's certainly continuous. So there, the left side go to the right and the right side go to the same point, and when it is equal to, it is also that point, and that makes it continuous. Right, that's 16. Right, intermediate value theorem. So usually it is more general than this, but in this scenario what we have here is there's a 4 and 5, and let's say we have, this is the function. It will be easier if we use the calculator here. Right. So first we enter the function into y equal to 2x cubed. I use that will be faster than the x cubed. 7x squared minus 9x plus 4. Right. Let's evaluate the function. So here is 4 and 5. We can just hit second table, and we have 4 and 5. So we have f of 4 is equal to negative 16, and f of 5 is equal to 34. We can also use the trace. Second, calculate values, enter 4 and then 5 in for x. So when x equal to 4 and when x equal to 5. Right. So that's the calculation. Now we have f of 4 is equal to negative 16 and f of 5 is equal to 34. So because this is a polynomial function, it is continuous. Continuous meaning from this point, when connect the point, the graph must cut the x-axis as that point. So there is a solution between 4 and 5. So because this is opposite side, they have opposite side. By intermediate value theorem, there must be a 0 between those two numbers, 4 and 5. Right, next, average rate of change. That is the same thing as the slope of the secant line, the formula. F of B minus F of A over B minus A. So here we have the function is square root of 2x. So that will be square root of, we're going to put 8 into the function. And then we're going to put 2 in it, subtract them, and then 8 minus 2. So if we have, I should say from the beginning, let f of x equal to square root of 2x, then we have f of 8 minus f of 2 over 8 minus 2. So that is exactly like this. So that is 16, square of 16 is 4, and square of 4 is 2 over 6. So 2 over 6 is 1/3. Where the function is continuous. Right, so here the few things we just need to watch out for rational function. The denominator is not equal to 0. And inside of an even root, have to be greater than or equal to 0. We cannot have the square root of a negative number. So for an even root, anything inside that have to be greater than or equal to 0. Right. So for this, negative 5x defined everywhere, continuous everywhere. We don't have to worry about it. For this one, just need to make sure that the denominator is not equal to 0, otherwise it is undefined and therefore not continuous. So x not equal to negative 5. So if we want to write the interval, to be on this side or on that side. So we have negative infinity to negative 5 or negative 5 to infinity. And this one we need to, this is fine where the function is continuous. So we need inside an even root to be greater than or equal to 0 and solve for x. So for x, subtract 2 on both sides and divide by 2. So x is greater than or equal to negative 1. So it is continuous if it is greater than or equal to negative 1, or from negative 1 to infinity. So that is where the function is continuous. Times 10. Right, 21 and 24, 21, 22. I think I only need to do 21, which we haven't done yet. Right, so to write the limit statement, we're gonna write the proof forward, and then we write it backward. The actual proof is the backward. Right. So what we start with is here where we start with this statement. So we start with the function minus the limit less than epsilon, and at the end we're going to end with x minus c or a less than delta. Right. So in this problem, c is equal to 1. The function is 5x minus 1, and the limit is 4. Right. So we go from here back to here, and whenever we write the proof, we will write this in reverse. We'll see. Right. So first, the function 5x minus 1 minus the limit less than epsilon. Remove the parentheses. We have 5x minus 1 minus 4, so that's minus 5. Let's factor out the 5. And we can split the absolute values. By split, I mean this. Or we take the 5 outside the absolute values, it doesn't matter. So which will be 5 x minus 1, absolute values x minus 1 less than epsilon. We can divide by 5 on both sides. We have x minus 1 less than epsilon divided by 5. Right, now we have x minus a number, and that one must be c, which is good. That's exactly what we want. So all we need to say is we're going to choose delta to be epsilon divided by 5. So this is the proof. This is just the scratch. The proof is this. For every, or I should say for any epsilon that is positive, we can choose delta to be epsilon over 5, so that now we write this in reverse. X minus 1 less than delta, which is equal to epsilon divided by 5, and we write this in reverse. 5 x minus 1 less than epsilon, 5 x minus 1 less than epsilon. Bring the 5 inside, multiply it out, and then 5x minus 1. So exactly we write this in reverse. And here note that what we have here, this is the function, and this is L. Thus limit of 5x minus 1 when x equal to 1 is equal to 4. So that is the proof. To write this is kind of backward. So the sketch, we start from here, and when we go where we can have x minus c less than delta, we can match them, and we should have delta equal to epsilon divided by 5. And with that, we write everything in reverse, and we have the proof. and I will let you do number 22. With that, we finish on the question on this review. I hope you found this helpful. Thank you for watching.